Great. Thanks, Donna. Yeah, a bunch of us went to Dinosaur JS about a month ago.
I'm out.
Difficulty, stand by, please.
Everybody mute their laptop.
Cool. So Dinosaur JS is a one-track JavaScript conference hosted here in Denver. 4 of us attended, and we're here to give you a couple highlights of the 10 talks that we saw. This is the first year of the conference, and it's part of the JSConf family of events that go on around the world. MC was Jen Schipper. It was pretty entertaining. She works at Goku, I guess. And I suspect they called it Dino.js because the dinosaur ridge in town. Too many things called Front Range or Mile High or Rocky Mountain, whatever. So it was hosted in the Oriental Theater, and it was a good time. So yeah, my talk is on refactoring, and it's a there we go. Better volume. So Rebecca Murphy did a talk called "Making It Better Without Making It Over." AKA refactoring. So basically, she's a well-known front-end developer and conference speaker. Her talk on refactoring began with a story about her findings in the Indeed.com code base when she first started working there. And to set the audience up for the 6th talk of the day, she stepped back in time to talk about the state of front-end development around like 2007, 2008. When the code she was reviewing was written, it was a time of monolithic frameworks and like jQuery and Dojo, YUI, and things like Backbone.js made writing a lot of code accessible to jQuery devs. So she wanted to impress on us that growth was not necessarily bad, but a growth without strategy for managing it is. It's easy to feel like the only way to make things better is to start from scratch, but it can be easy to fall into the same traps you're already in by using something new if you've never used it before. So she gave us an example of some code that she stumbled upon, a function called onInitialization with about 40 parameters. And she decided to refactor this by moving some parameters to an object, aka a model, and used a framework like Redux to manage the state, which made it a whole lot cleaner and kind of separated a bunch of the concerns. Then she went through and added a package.json file to the project and included ESLint as a kind of guardrail and fixed the errors that reported. So that's kind of a way to elevate JavaScript among the team by providing like a right way that can be verified, and something that we already do on most, if not all, projects here. One thing she does differently, however, is she added a Git hook that lints the code prior to building it on Jenkins, which prevents any unlinted code from being deployed. And I haven't done too much digging, but I haven't seen that before. So then lastly, she added some real-time analytics as feedback for the team while they developed key user features. Information she wanted to know included what's important, what do we need to know about, what will be bad if it's broken, and what are key actions that a user can take. And once implemented, she kept an eye on the waterfall view in the developer tools for custom events. I'm not sure you can see them, they're kind of small, but they're the ones in yellow here. This allows the team to establish a front-end performance budget on how the page should be loading and gives us metrics on whether we're within those budgets. So just real quick, some key takeaways I found interesting. Get a couple quotes here. So the first one is it's unrealistic for you to learn a framework that solves a problem you've never experienced. It's important to look at the value proposition, and only after having tried using this technology you already know does the framework become a tool to solve the problem. In other words, you gain perspective. So in this rapidly evolving world of JavaScript development, it can be really difficult to stay up to speed in that regard. But I guess that's why we have lunch and learns. Okay, so second one is every technology decision is eventually regrettable and usually made in good faith with the best information available at the time. Doing web development is a lot of times an exercise in empathy. And this is something I've seen at Kenzan that I especially like. We don't limit ourselves to any one technology. We use the best tool for the job at the time of the, when we start the project. We try to balance foresight with rapid development, and when it's time to start a new project, we take what we've learned and find new ways of doing things better. And granted, a lot of our projects are large and ongoing, but I think everyone would benefit from having a project retrospective shared with the company as they finish. So next one is framework or no, JS growth is unbounded in the absence of constraints. So you can't avoid JS growth, you just have to manage its complexity. And for the most part, we already do this with things like John's Papa's style guide and ESLint. What I think we could benefit from is a standardized project structure that all projects share, or a company standard, like what should be unit tested and how. And admittedly, this can be a moving target, especially with continually evolving best practices and when each project leverages different technologies and has different needs. And for example, when we eventually start using Angular 2, the Angular CLI can automate some of those tasks and create a common file structure, similar to Yeoman or however you say it. Okay, next one is education is a powerful enabler. And also teaching how to care and what to care about is immensely transformative. It's easier to teach someone how to use a framework than to teach the fundamental problem-solving skills, which is why everyone jumps to the framework. Obviously, everyone has different backgrounds and learns differently, and I think that it's great that Kenzan encourages us to participate in conferences and watch courses on Pluralsight and go to meetups and attend lunch and learns, and there's no shortage of options for continuous education. And thankfully, the culture here encourages people to ask questions of anyone. So lastly, okay, I was right. Last quote is, building for the web is better today than, say, 10 years ago. Hopefully we can always say that. A lot of what Rebecca mentioned are things that we already do, but I found it helpful to be reminded of why we do those things and consider how we might do them better. I encourage everyone to do the same. So that kind of leads me into, I've got some links here. So the next talk I'm kind of merging into this other one is one called Server Farm to Table, or How the Internet Works. This one was done by Jenna Zygan from DigitalOcean. She's a programmer there who gave a very fast-paced and high-level talk on how the internet works. So I won't go into too much detail there because that would take the entire time here, but basically here are the highlights of that. So first thing, obviously, IP address lookup, what happens when a client tries to visit a site, and a couple ways they get back the proper IP address mapped to the domain name, like a router, DNS server. Next one would be opening a socket. So once they found the server, they establish the connection. Dealing with any security, so if a server offers a certification and a public key, secret message would be attempted by a client, decrypted by the server, and then both report that they're finished. Next step generally would be HTTP request and response. Basically, the browser sends request headers, server retrieves data and sends the response headers and data back. Following that would be parsing, which is done by the browser. And there's a kind of a lengthy step involved here, but basically it goes from bytes to characters to tokens to nodes to rendering the DOM. And while the DOM is rendering, there's this thing called the rendering tree, which is also being developed at the same time. It's basically a visual representation of the DOM, so things that will be shown. So like display none things won't be in this. Then it'll load linked resources like style sheets, scripts, images, media, and then it'll calculate the page layout, things like position, sizes, colors, fonts, etc. And then it goes on finally to rendering, which is where things get painted or displayed in the browser window. When users interact with a page, it's otherwise modified. Things like DOM manipulation, content changes, CSS class changes, maybe a browser window resize. The page requires a repaint and a reflow possibly. So it's kind of a iterative process. And that's kind of a super fast version of her talk. And so at the end, she briefly talked about the up and coming HTTP2 protocol, which sounded like we'd have some things to refactor in our code bases before we could use it. So I thought I'd dig into that a little bit. But before I do that, it might help to get a little more background on the current version. So, real quick, some nerd speak for you. HTTP, or Hypertext Transfer Protocol, is basically about requests and responses. It's an application layer protocol used to deliver hypermedia, which is basically assets like HTML files, CSS, JSON, PDFs, things like that. So it's currently at version 1.1, which is what most websites have been using since about 1999. Some sites also have been using SPDY or SPDY, which is a newer Google protocol that's became kind of the foundation of HTTP2. I'm just going to say version 2 because that's a mouthful. So version 1.1 is not known particularly for being good at retrieving and delivering many resources simultaneously due to, well, many reasons, but primarily browsers' limitations in opening multiple connections to a single source, single server. So downloading assets is a serial process, one after the next, which is known as head-of-line blocking. And there are several ways of getting around that limitation that a lot of front-end developers use quite often, such as concatenating files or creating image sprites, domain sharding. An example of this would be using a CDN, which can live in a couple different origins or servers, locations, and this allows browsers to get around the head-of-line blocking by downloading multiple assets at the same time. So some quick highlights of version 2. There's a number of improvements over the SPDY and version 1.1 protocols that were included in the V2 spec, but here's a couple that apply to us specifically, front-end developers and stuff. So first would be multiplexing, which allows for multiple requests for assets on the same domain using a single connection. And this is made possible by header compression, which is basically the same information as the headers in HTTP version 1, it's just compressed. Next thing is stream priority, which allows browsers to specify the order they'd like to receive assets. And the last one is this new server push feature, which can send resources before the browser requests them. All of these have shown to give web performance, page loading performance about a 30% performance gain. So some fun facts. The spec was finalized about a year, maybe a year and a half ago, February 2015. Lost my place. There we go. So it requires secure connection. It's already implemented in a lot of the major browsers, and you can kind of see this chart here. There are some caveats here and there, but for the most part, all the browser vendors are on board. It does require secure connection, which is HTTPS, and it requires both browser and server support. So both have to be present for that, for version 2 to work there. It's usually a good idea to check your site's browser usage statistics to confirm it's a good idea to make that switch. But let's see. Despite all these awesome features here, it's some of the workarounds we're doing currently on the front end can actually hurt our page load times if we're using HTTP2. So I want to go into that now. What we can do to fix that. I lost my place again. Okay, so there are a number of things we can do. First, we can stop concatenating files. Kind of defeats the benefit of individual caching that we get with multiplexing. When concatenated, if one line of a long file changes, the entire asset needs to be re-downloaded. And I think what the main theme here in version 2 is that requests are cheap. Another way you can do is stop making sprite sheets. We just don't need them, other than certain cases, as it might achieve better compression. But for the most part, we can keep our images independent of each other. Another thing we can do is stop inlining images using data URIs. And this generally generates larger files, and it doesn't leverage the stream prioritization. And also, you can't cache the individual assets that way. Another thing is we can stop domain sharding. By doing so, we're limiting the number of DNS lookups and connections, concurrent connections. And lastly, we can move connections to TLS, which is the HTTPS prefix, better security in general, and that's the way most of the web is heading anyway. There are free certificate authorities out there like Let's Encrypt, and I'm sure prices have gone down, but it's required if you want to leverage HTTP2. So going forward, we should focus on caching behavior. Requests should be the small granular resources that can be cached independently and delivered asynchronously. We can organize assets by website, section, or component, which a lot of times we do. We can keep using CDNs. It can be complicated to set it up, but it is possible to consider a CDN as one origin. And lastly, we can continue to minimize the size of our requests and responses, minification of files, optimization of images, file compression with gzip, things like that. So those things are still valid and useful. So it's still pretty early in the HTTP2 lifespan. So the community has a lot of opportunity to find new and creative ways of leveraging this new protocol and help continue to push the web forward. So it'll be interesting to see how that continues. Then I got some links here if you're interested, and we'll post these later. Yeah, that's it for me. Any questions? Cool. So we'll ask again at the end. Oh, you have a question?
TLS, nobody is on TLS version of
Okay. Right. That was taken out of the requirement. So the comment was no one's implemented a non-TLS version of HTTP2, and I think originally that was in the Speedy spec, but they took it out. However, all the browsers have basically said, yeah, we're not doing this without HTTP. Yeah. So they're requiring HTTPS in combination with HTTP2.
You know, also their compressing headers actually have pretty big on the side.
Mm.
So there's a lot of headers.
Right, and I think that's part of what helps us get the concurrent. Cool. Cool. So I guess I'll pass it over to Sean. Or are you
I was going to go next.
Okay, sorry, Marie, just kidding.
Cool. We're going to switch the screens over. There we go. Okay, so I'm going to talk about accessibility in web applications. So I thought it was one of the talks that really struck me as interesting at the conference because I'm pretty new to development, and it honestly is something I had never even thought about before. How do you use the web when you can't see, or how do you use the web when you have severe color blindness and things like that? I just thought it was a really interesting topic. So I want to kind of walk you through some factors that affect accessibility for web applications, and then I'm going to talk about the specific challenges of accessibility when it comes to single-page web applications. That's something that we deal with very, very often here at Kenzan. It's kind of the future of the front end, so it presents some special challenges when it comes to accessibility. And then I'm going to kind of show you some examples of tools that are out there for testing accessibility in web pages and some example screen readers and stuff that can help us as developers test our code and make sure that our code is the best it can be. So first off, I'm going to walk you through some factors that affect accessibility when it comes to web design. And there's a number of factors. One thing that I think gets overlooked a lot is responsiveness. So actually having a web page display well on a cell phone and an iPad and a desktop and a TV it really is an accessibility concern because some people can't afford computers and the only way they have to interact with the web is through a cell phone. So you want them to have the same experience that you have here on your really nice computer. Another thing that I thought was really interesting is color. So a lot of times we use color in our web design to tell kind of a story and to give the user input. But if you have a color blindness, say between green and red, so on the slide you can see that for someone with a red deficiency in the way they view color, the green and the red look very similar. But I'm sure you can think of times that you've used a website and something has flashed red because you did like an input wrong or something like that. But with a color blindness, you can't tell if that's right or wrong or what that's trying to tell you. That was interesting to me. Also typography. So for the basic examples, of course, you want a header to be bigger than your body content. You want a clear distinction between different pieces of the page, but some things that I had never considered before were all caps. So screen readers actually can trip up on headers and things that are displayed in all caps. They don't necessarily know how to pronounce the words, and sometimes it can string the words together improperly. And so as developers, a lot of times we use all caps to denote a header, but that might not be the best approach. Another example is justifying text. So it can look really nice to have clean lines on both sides of your text, but for people with dyslexia or different reading disabilities, it can be really hard to read when the gaps between the words are inconsistent. So it's these little things that make a big difference in making your page really accessible to everyone. And then finally, another one is form design. So a lot of us have seen forms like this top this top one right here. They look really nice, really streamlined, but for someone who's using a screen reader, when they're scrolling through that form, they're not getting any input about whether that input is required or not required. For the passwords, they might not know how many digits or how many special characters they can use or anything like that, but if you look at the bottom layout that's a little bit more accessible, when they're tabbing through those fields, they're going to get all the information they need before they even reach the input. So it makes it really easy for them to get these things right and scroll through your page without any confusion. So when it comes to single web page applications, this is really for screen readers in particular. So people that are blind who need to navigate websites with the keyboard, it can be really difficult because the page never reloads. So when a page reloads, an element will be given focus, and you'll get a clear definition of that something has changed. But if you're using a screen reader with a single page application, you may hit a link and you may be taken to a new page where nothing is in focus. And so you don't know that anything on the screen has changed. So as developers, we need to be really mindful of this, and we need to use special tools like JavaScript and jQuery to put elements in focus and give indications to screen readers and to the website that something has changed here on the page. We also use a lot of elements in current applications that they show and they hide only they'll show only for a certain amount of time, or they'll have no elements on them that really take focus from the browser. So for example, a modal or a toaster box or something, there's no link there and there's no header. So if you're just quickly scrolling through the web page using your keyboard, those elements will be completely skipped. So if you have this modal box that tells you something has happened or there's an error, or are you sure you want to submit this? If that box doesn't gain focus, someone scrolling through on a keyboard isn't going to know that there's an interaction that they need to have with their computer right now. So it's really important that as developers, we're making these transitions and these elements and these changes very, very obvious to all of our users, not just people who can physically see the screen. So two tools that I found really, really helpful when I was kind of learning about this and writing this presentation were the accessibility developer tools for Google Chrome. So that's a plugin or a web extension for your Google Chrome browser, and it will allow you to do an accessibility audit on your page, which is really, really cool. You just open the page up, you go into your developer tools, and you go to your audits, and you can run an accessibility audit, and it will check your page against all of the current regulations and restrictions that are placed on the web for accessibility. And it will tell you whether you had any severe errors, which are things that mean technically you are out of compliance with accessibility requirements. It'll tell you if you have any warnings, so things that you should consider fixing but aren't going to put you out of compliance, and then it'll tell you all the tests that passed. So you really get a good and really, really quick rundown of how accessible your page is. So that's a great tool for us trying to make our applications here at Kenzan a little bit better. And the second one was the Chromevox screen reader. So that's just a screen reader plugin for Chrome, and it allows you to interact with the page via your keyboard. So we're going to go through two examples right now. One that I thought was done really well, and we're just going to quickly scroll around with the screen reader on, and I'll show you how that works, and then we'll do one page with a little bit of room for improvement. So let's do this guy first. So this is the Web Accessibility in Mind page. So you hope that it's pretty good, and I think it is.
Web Accessibility in Mind tab.
So you can see when you open the page, you're immediately put into focus on this top element. And if
Skip to main content.
Tab,
enter a link.
I'm allowed to skip straight to the content. So this means that when I'm navigating through the page, I don't have to scroll through the nav bar every single time, which is really nice. So I'm going to skip to main content.
Article. We have web accessibility in mind. Heading 1.
It places me right onto a header, which gives me a really clear idea of what this page is about. And then I go to next.
Accessibility training. Link heading 2.
And it gives me these links to different parts of the page with really descriptive titles. So I really know, if I click this link, what am I getting into? And I know what's going on this page. So we're going to navigate.
Copyright. Wrap to top.
to a new
Skip this navigation
page.
list with 4 items.
So we're
Services.
going to go
Visited link list item.
we're going to go to the services page.
Services. WebAIM services. Skip to main content. Internal link. WebAIM. Web accessibility in mind. Link heading 2. Navigation.
Okay, it's just going to go through the entire page if I let it. But I wanted to point out that this is a single page application. We just changed to a new page. It puts you automatically in focus with the top of the screen so you know what's happening. I can tab, and now I can skip to main content again, and we can navigate the page again. So it's very, very simple, very easy, very fluid to navigate this site with the keyboard. So let's go back to the next example.
Sign Kenzan. Skip to content. Internal link.
So we're looking at Kenzan's web page right now for accessibility. So we do have a skip to content button, which I thought was interesting. So I'm going to skip to content.
Leading edge technology delivered with a human touch. Main.
It brings me to this image with a quote or something, but it doesn't give me much information about what I'm seeing or what I'm doing here. So I'm going to tab to the next element, see if I get more information from that.
Vertical. Pivotal _ ready _ partner _ advanced _ logo _ gradient.
Not much there. So now I'm kind of confused. I don't know where I am. So I'll try and find maybe the nav bar and see what I can do with that.
Banner. Kenzan. Okay, navigation list collapsed with 6 items. What we do? Visited link list item.
Cool. What we do. That sounds good. I want to know what Kenzan does.
What we do, Kenzan. Skip to content. A soup to nuts approach to a complicated industry. Main.
Okay. All right. Well, maybe I'll get more.
Vertical. GitHub page. Link.
Okay. So now it's taken me to this link. It doesn't have much description. It tells me it's a GitHub page, but I don't know what it's a GitHub page for. I don't know where it's going to take me. So these are things that you need to think about when you're making an accessible page. If you're just tabbing through, are you going to get the information that you need? The links, are they going to have titles that are descriptive enough to really tell the user out of context what this link is about? So I think this page has a little bit of room for improvement, but there are some good features already in place. So that,
GitHub page. Link.
Oh, better turn that off.
GitHub page.
So I'm just going to conclude with how we here at Kenzan can build more accessible applications. So for this talk, I prepared by listening to the web accessibility course on Pluralsight, and I found that really, really helpful. I feel like I learned a lot from that, and it only takes about 45 minutes. So for all of our UI developers, our front-end developers, and even our QA team, I don't think it's a bad idea to run through a course like that and just get a better understanding of what factors go into accessibility and what we should be looking for in our applications. Another thing is there are a lot of accessibility testing tools that we can actually build into the frameworks we're already using. So I know previously we've done a lunch and learn on Protractor, which is a end-to-end testing framework for Angular. And Protractor actually has accessibility plugins, which I thought was really cool. So we can just link our Protractor up with the Chrome Dev Tools or with this testing package 10.io, and then we can just add them right into our existing frameworks. Every time we run our Protractor test, we're also running our accessibility test. It's a really easy integration, and it can give us just some feedback on how our new features are doing when it comes to accessibility. And then finally, because a lot of these things are becoming more important, more recognized, and some of them are becoming mandated, we're starting to see federal regulations when it comes to web accessibility and stuff. A lot of the newer JavaScript frameworks are being built with accessibility in mind. So they're equipped with ARIA-enabled components, which stand for Accessible Rich Internet Application Enabled Components. So these are things that are going to give a screen reader a lot of information about what certain features on the page are doing, and just give that screen reader information to tell a user what they're looking at. So these are built into a lot of the new frameworks. Also, a lot of them have an A11Y test infrastructure or an accessibility test infrastructure built into the framework. So it really makes it easy to test. And I think that these are things we should start looking at here at Kenzan and making sure that we're delivering a product that is is going to be accessible to everyone, not just because it seems like our obligation as developers, but also because these are things that will become at some point mandated and that we're going to need to comply with, so we might as well be ahead of the curve. So that's all for me, and I'm going to hand it back to Sean to wrap up.
Other questions?
Oh, and if anyone has any questions, I'd be happy to answer.
I just have one comment. There's already an NG ARIA module for Angular 1, which makes it so that if you're using things like ng hide and show, it'll just add the ARIA tags for you and update them for you, which is kind of nice.
All right. Well, I guess I'll get started. Awesome. I am unmuted. Okay, so I get to talk about the new JavaScript hotness that was going on at the conference, and which is Electron. And we got a talk by a guy named Evan Morikawa about Electron and how he's using it to build a desktop email client. So what is Electron? Electron is a platform for building cross-platform desktop apps with web technologies. That's kind of a handful, so let's go through and kind of figure out what each of those mean. So when I say cross-platform, I'm talking about 3 different platforms, 3 different operating systems. We've got Windows, we got Mac, and we've got this operating system that looks like a sad penguin called Linux. And Electron will compile down your app that you build into formats that work with all of those operating systems. It's also for building desktop applications. So I'm not talking about mobile applications. I'm not talking about web applications. I'm talking about applications that are in the dock of your operating system, things that you open up on a daily basis and leave open all day, perhaps, or just use in that regard. And you can build with web technologies. So that means that you're able to build these applications with HTML, CSS, and JavaScript. And I know some people might react and say, hey, JavaScript probably isn't a powerful enough language to be building applications for the desktop. But I think you'd be surprised because a lot of applications out there already are using Electron to compile, and you might actually use them already on your computer. So this is just a screenshot I took off of the Electron website, and this is a handful of applications that I grabbed. There's a whole bunch more, but you'll see some applications on there that you might use on a daily basis. So there's the Atom editor made by GitHub, there's Slack, Visual Studio Code. I think Docker even has an application that was built on Electron. And in order to give this presentation, I decided to get my hands dirty and try building an Electron app. So for your viewing pleasure, I have an app here called Scrumptious. And basically, I'm scratching my own itch with this app. It's really just in it's in alpha right now because it's not even fully functional yet. I just wanted to get it up and running for today's talk. But essentially what it does is it hooks into your Jira account. So I'm going to log in right now with my credentials. And I logged in. And what it's doing, well, the whole idea behind it is I wanted a productivity app for my desktop that I could just run on a daily basis and add my own subtasks and my own tasks alongside of the Jira tasks that I have to do. And also be able to keep track of that without having to open up a browser every 2 seconds and find my bookmark to Jira in order to get back to where I left off. So you can see here that all of my tickets that are open right now just popped into this application. I'm going to click on a few, add them into my running tasks for the day, and you can see I can interact with these tasks and say that I've completed them or turn them off. I think eventually this could actually hook up to the Jira API and close a ticket for you or do any sort of stuff like that if you want. But the really cool part about this is because it was built with web technologies and because it was built with Electron, I now have access to the Chrome developer tools and a whole bunch of other stuff. So you can see right here, I just opened up DevTools on a desktop application. And I'm running this locally on my computer, so that's why I can get access to the DevTools. Once you compile your app, no one's going to be able to access this stuff. But while I'm developing, I can look at what I'm developing. I can, potentially modify CSS to see what it looks like if I change colors or do anything like that. You also have access to different performance measurements. So like I can capture exactly what's going on with the paints and everything else on the screen while I'm playing around with the application. And I can see that performance in the Chrome DevTools. And Chrome DevTools are super powerful. So I've heard, and I think Evan in his talk spoke about how a lot of desktop native developers are kind of jealous when they see that they can get access to these sort of things during development. And maybe it could be a better environment for building desktop applications. So let's jump in to a little bit of history here. So in the past, a lot of times if you're a desktop application developer, you have to learn specific languages and frameworks in order to develop for the desktop. And so I don't think a lot of people were able to develop across different operating systems very well, just because there's a knowledge gap there. You got to learn different frameworks, different APIs, different languages potentially. And so the fact that Electron lets you do all of this in web technologies, it really opens up desktop development to a wider audience and also lets you build your app in just one technology and deploy it to all three operating systems. And I think there's a little caveat there. I don't know what the details are of this, but I heard that in some ways it's not quite as low level as a lot of these other or traditional frameworks that let you develop for desktop. But the fact that some of these complicated applications that we use today that were built on it, I believe it's probably sufficient for a lot of applications. So in order to bridge the gap, a while back, someone open sourced a project called Node WebKit, where they tried to allow for developers to use JavaScript in an environment that would allow them to build applications for the desktop. And this was kind of the basis for Electron and everything else that came after it. The problem with this was it was essentially just a web page in a frame when you built for Node WebKit. So you didn't get a lot of the rich functionality and access to your operating system's special features with this development or this toolkit. So at some point, GitHub decided that they wanted to enter the space of code editors and came out with Atom, the Atom editor. I don't know if a lot of people use it here. It's a pretty good editor. It has a lot of backing. A lot of people are using it for JavaScript development. And the whole idea behind Atom was that they wanted to create a code editor that web developers could hack on. So they had to create a specific interface for the developer to write in JavaScript and be able to create extensions and plugins for Atom. And that's kind of where Electron was born from. They started calling the portion of Atom that allowed developers to hook into native functionality, the Atom shell, and that eventually became the open source project called Electron. And Electron, behind the scenes, is basically the coupling of Chromium, which is the open source browser technology, and Node. And since it's packaged together and you build from that package, they usually have the most up-to-date version of Chromium and Node packaged into Electron, which just kind of sounds like a nicety, but when you think about it, it extracts away a lot of the complexity that we have today in front-end development. If you're developing an Electron app, you don't have to worry about 3 or 4 different browsers and everything else that comes along with that. You're just developing for the newest version of Chrome. So you probably don't even have to use vendor prefixes or any sorts of backwards compatibility while you're doing front-end development. And same thing with Node. It comes with all the native Node packages that are in the newest form, and I believe Node 6 is packaged in Electron now, and that will let you use a lot of the ES6 functionality without having to use a tool like Babel to compile down. So what is Chromium? It's basically a browser backend made in C++, and this is the main process. And the main process spawns up a bunch of renderers, which would be known as the tabs in your browser. And they communicate. The backend communicates with the renderer and tells it certain things to do. So like when you close your browser window, it communicates with the main process saying to close down that renderer and shut the window off. So what Electron does is it takes that Chromium, the entire Chromium project, and it injects Node into the main process. So now you don't have to deal with this gook of C++. If you're a front-end developer, this sounds really nice because you get to write JavaScript for the main process, and they also injected Node into the render processes. So essentially the main process controls what windows are shown inside your application, and each window would be considered a renderer. So many times applications will have one renderer, but you might have to click on something that opens up a new little window within your desktop application, and that would be a new renderer. So just to show you how cool this is, I will jump back into my app. Here. And let's clear this out. So we are basically in Chromium right now, but we also have access to Node. So if I want, I can type in document, and I get access to the DOM, which is, typical front-end technology. When you're inside a browser, you get access to the DOM. But at the same time, I have access to requiring Node packages. So I also have access to the FS Node native Node package, which gives me access to the file system. So now I can read, write, and do whatever I want to the file system and also interact with the DOM from the same environment. It sounds weird, but it's super powerful, and I felt while I was writing this very spoiled. I wish I could use this sort of technology all the time. So one thing I'm going to show you really quick. I know there's some non-developers watching right now, but I just wanted to call this out. I was writing some code for interacting with Jira, and they had security, cross-origin security set up on their API. So all of my AJAX requests that I was sending out were erroring, and they were sent back to me with like a 401, saying that I didn't have access to that domain because it was a cross-domain violation. So what I did is I installed requests, which is a Node package, and I'm running requests directly from my front-end React code. This application's built in React and Redux. And because it's making a server-side request and not an AJAX request directly from my code here, I'm able to bypass that security and get the response back that I need. So that was pretty crazy. Like, I've never been able to do that before in development, and it kind of blew my mind. It made me realize, like, this is a really fun environment to develop JavaScript in. I mean, there's like a whole bunch of possibilities once you talk about bringing together Node and the DOM. And some that I've heard people talk about are being able to access databases directly from your front-end code. So you basically could write a query from your front-end code and hit your database, get data back from it, or you could set up observables that would react to any changes to a database query and pull those directly into your application immediately. I mean, your database also could be in the cloud, but a lot of times for these applications, people will set up in-memory storage databases directly inside the application, and it just saves that data directly to your computer, just like a normal desktop application would. And the next time you open up the application, that data is there for you to use and manipulate and do whatever you want with. So there's also, in addition to just having access to Node and the DOM at the same time, there's Electron APIs, which allow you to do specific things that you might need in a desktop application that have to do with the operating system itself. So open this up here. They have a pretty awesome tool you can download from GitHub and run locally on your computer that gives you documentation for their APIs. And inside of this, it gives you code snippets. So say I want to learn how to create a new window. I can click on here. There's a code snippet in here, and they use the same code in here to actually give you a demo. So it shows you how to write that code, and it shows you what that code does. Things like customizing menus are specific to desktop applications, and so Electron has opened that up in an API for you. There are certain things that are slightly different across platforms, and I think one of them is push notifications. Electron allows you to use push notifications, but I believe there's different implementations that you have to write for the different operating systems. But it gives you access to stuff like the clipboard, system information, the tray. You can put your app up in the tray if you want, so you just see that my Electron app appeared up here. And you have access to all that sort of stuff. So one thing to keep in mind, and Evan in his talk brought this up a whole bunch, is that when you're building for native, you really want to not build something that looks like a web application. This is a different platform. There's different rules regulating the design behind building a native application compared to building a web application. And also, everything looks different between different platforms. So like you can see here, I have Chrome on a Mac on the left and Chrome in Windows on the right. You can just see the Chrome around the browser itself is even a different color. The opening, closing buttons are all completely different. And I would assume the majority of the differences that you'll see between different operating systems are visual changes. So things that you would change in CSS and make different with CSS. And there's also a little hook into this that you can use in Electron to make visual changes based on what platform you're running the application on. So since we have access to Node, we have access to process.platform, which would then tell us if we're using a Mac, Linux, or Windows. And the cool thing about this is you can take that, set up a conditional statement that adds a class onto the body or the HTML document saying what platform all of your code is in, and that class can then toggle styles. So depending on what platform you're on, you can write style-specific CSS for that platform and have it toggle inside of the application. So I can show you here. If I do process platform, tells me I'm using Darwin, which is the operating system behind OS X. So we know that I'm using an OS X app right now, and I could potentially set specific styles based on that. So that's about it. We're hitting 1 o'clock right now, but I've put a bunch of learning resources on here and tools for Electron. I open sourced my little project that I'm working on, so a little shout out for the project. If anybody wants to help me out, build a React Redux Electron app, there's that URL. There's also the Electron Starter, which is an amazing place to set up a boilerplate for a new application. It's so simple. and it gets you running right away. The amount of code that you need to actually start up an Electron app is very minimal. The API demos, which I showed you in that little application I have on this list, there's a good resource list on GitHub also to read from. And I really like the Pluralsight video tutorial that's out there. The person who's teaching that course gives you kind of an unconventional look at how to write Electron apps, and basically gives you a way of writing them from scratch without using any sort of crazy JavaScript frameworks on top of it. You really don't need Angular or React or Redux or anything like that to build an Electron app. There's also a GUI kit that gives you all of the CSS for OS X called Photon Kit. There's a database built specifically for Electron that's in memory called NEDB. And there's also the Electron Packager, which does all of the packaging of your application to different operating systems. And that's about it. So if anybody has any questions, let me know.
I want to go make stuff with Electron now. Yeah, it's pretty cool. With accessibility.
If you want to help me out, I got an open source project.
I'm watching it.
Any questions from the phone? Going once. All right. Guys, you did a great job.
Yeah.
Terrific presentation.